Hey, this is Peter, and welcome to another Take a Break with Valley CAD. So, I really enjoy working with sheet metal features inside of SOLIDWORKS. I used to be a sheet metal programmer and designer, so I used it quite often, and I still use it quite often today. And one aspect of working with sheet metal is working through this concept of convert to sheet metal. And I really started to appreciate that as I got more and more in depth in the software. And so we're going to apply two variables to this. One of them is working with a solid geometry and trying to make a housing unit around it. And then the other one is working with imported geometry, so a dumb solid. So if you want to try to click along with this video, I have a link down below for that imported geometry, so you could try to work on working with a non-native SOLIDWORKS file to make a sheet metal part out of it. So anyways, go get your favorite cup of coffee or tea, and I'll see you in SOLIDWORKS in just a click. Hey there, welcome to SOLIDWORKS. So here is the part that we're going to be working with that we're going to convert to sheet metal. At least this is the first example we're going to look at. So this example, think of it that you have a mass like this, or a volume, and think of it that you need to make a sheet metal body that goes around this. So to go about this, it's actually really simple to do. If we come up here to the sheet metal tab, it has this little button called Convert to Sheet Metal. Simply clicking on that, you'll see that my solid object here went transparent. What we're going to go through now is apply sheet metal properties to this solid geometry. So starting off, what we're going to look at is our use a gauge table. Using gauge tables in SOLIDWORKS sheet metal is, I think it's one of the most crucial steps to understand and implement for your company. I'm not going to go into gauge tables in this video, but if you do want to learn about it, we do offer a 2-day sheet metal class. You learn the basics of how to start up a sheet metal part, moving through how to convert products like this, to work in a multi-body design technique, and how to make drawings from that. So if you want to learn more about that, give our sales team a call. You'll see our phone number at the bottom of the screen here. It's at 559-726-2276. All right. So now that we got that set up there, the next thing that we need to look at is our sheet metal parameters. We need to specify where's our fixed face, where's everything going to be bent from. So in this scenario, I'm going to say it's this bottom face right here. And you'll see here that SOLIDWORKS shows up with this like little yellow rectangle shows up, right? Or a little plate. Well, that's actually 1/2-inch thick sheet metal right there. So I'm going to change this to, let's work in 14 gauge. And then with our 14 gauge selection, you can see how SOLIDWORKS made that little extrusion quite a bit thinner there, right? 14 gauge is actually 0.0747 and a steel gauge factor there. So now as we come in here, what we're going to be doing next is looking at some little check boxes. We have a reverse thickness. So right now my thickness is going into my geometry. Maybe I need to make it to where the sheet metal part needs to house this product here. So this is where that reverse thickness comes in. So as I zoom in, you'll see that my reverse thickness just flips the material. Easy. The next one down is called keep body. What this will do is if I have that checked and I complete this command, my solid object will still show up in my part file. Now that might be useful because you can actually do more than one convert to sheet metal in one given part file. So in this scenario, I'm going to make it to where keep body is actually unchecked. And then there's an override thickness. We're not going to worry about that. We're going to use our gauge table. So from here, because of my gauge table, I'll set up so that we're working with 1/8-inch radius on here. Now, after we come in and we specify those properties, now we're working with the convert to sheet metal properties. We need to come in here and specify, hey, where are my bend edges going to be? So as we come in here, maybe I want this to be a bent edge, and this one's a bent edge. So as I come in here and zoom in, you'll see that SOLIDWORKS adds a bend radius there for me. So here's a little gotcha when you're working with convert to sheet metal. I recommend do not come in with pre-made fillets on your part. Try to make sure that they are sharp corners. If you have a radius already, SOLIDWORKS will come in and say, oh, you have an existing radius here from a fillet command or whatever. I'm going to utilize that radius as to control my bend radius of sheet metal. I would much rather use the properties of my sheet metal control to control the bend on this, not some outside fillet. So that's just a little gotcha on there. I would recommend making it to where you're working with sharp corners. So now that we have that set up, watch what happens when I come in here and I'll click on this backside. Clicking on this, you'll see that SOLIDWORKS will come in and add that other flange for me. But notice here that SOLIDWORKS actually comes in and it trims away the corner there, because when this gets flattened out, technically those aren't gonna be touching. So when they come up, they make a nice sharp corner there. So it's really cool that SOLIDWORKS can actually figure that out for you. Now, as we come in here, you'll notice that we have rip edges and it says read only on that. That's what I was talking about with these two pink lines. SOLIDWORKS automatically added that. Now there's a variable here that's called rip sketches. What this does is it will rip your sheet metal. So for instance here, I have a one vertical line here. And by the way, when you use rip sketches, you can only have one entity, and it needs to be an open profile entity per sketch. And so you have to use multiple sketches there. And I'm sorry, I said one entity there. That's actually not true. You can have multiple entities, but you can only use one sketch per rip sketches there. So with this setup, I'm gonna say that one selection there. I'm gonna come in and click on this one line. Notice that SOLIDWORKS adds it, but you don't really see anything happening there. Yeah, not yet. So I'm gonna come back up to bend edges. Watch what happens when I click on this edge. SOLIDWORKS will come through and it'll bend from here. That's great. It's ripping from down there. But since I use rip sketches, it added a rip here. So it's actually stopping it early. Cool. Then from here, I could actually come in and specify this edge over here. And SOLIDWORKS will come through and form it around that little short leg there. Then from there, I can just simply click on OK. These other properties that you see about corner defaults, these are standard when you're working with sheet metal components. So I'm going to say OK to that. And now we see our final sheet metal body or housing for that solid geometry. And since I checked that parameter there for the, or unchecked it to keep body there, that made it to where it will consume that solid body. And there's my sheet metal body after the fact. Pretty cool. So that's one way to work through convert to sheet metal. And I like using that route if I have to work with an internal volume that needs to fit within a sheet metal component. Or you can actually use sheet metal features for like corrugated boxes if you want, or other boxes per se. All right, so now let's come in here. Let's work in another scenario. This is scenario 2 when you might use convert to sheet metal. So as you see here, I'm working with a dumb solid. A dumb solid is something that doesn't have any information in the design tree. So this is typically when you're transferring something from another parasolid file, like an XT file or a step or an IGES file. And so it gets imported into SOLIDWORKS and it's just a 3D mass. So what we need to do is add some intelligence to this. And so we're going to utilize convert to sheet metal. Now, before we get into this, I want us to verify how thick this wall is. So if I push letter M, I made that as a shortcut key. That's your measure command, which is under your evaluate tab, measure there. And so I'm going to simply click on this face and then clicking on this face. From there, you'll see that I have a 1/4 inch thickness. Awesome. Okay, so all the way around, I have 1/4 inch thickness. Now, when I come in and do sheet metal and I do a convert to sheet metal, you will see here, I'm gonna utilize, let's use a gauge table again. We'll say Valley CAD 2020 on there, steel. And coming in here, I'm gonna set this up so we're gonna be working with 10 gauge. So 0.1345 thickness there. And my fixed entity, I'm gonna make it so it's this surface right here. Now, as I'm coming in here and doing this, notice how it's going the wrong direction. Well, I think it's the wrong direction. I need to make it so it comes into the same direction as where the material is. So I'm going to click on reverse thickness, and also I'm going to keep body unchecked as well. So now that we have that set up, notice how, because I'm speccing out 10 gauge on here, SOLIDWORKS is going to ignore that 1/4 inch thickness and it'll make it so it'll be a 10 gauge piece of material. All right, so from here, bend edges, I'm gonna simply click here and I'll click here, and then I'll also click up on here. SOLIDWORKS will come through and bend these out. Now watch what happens if I came in here and I said, all right, with my bend edges, okay. If I said I want this one, and this one, that'll give me a whole different parameters of how this thing will look flattened out. but I want to show how you can actually verify your selection there. If I came in first and I selected on this edge, SOLIDWORKS is actually going to pop up saying, hey, this isn't connected to your fixed face, so it's not going to work. You have to click in order. So I'm going to come back in here, and we're going to specify on this edge here, and then this final edge up there. And then simply right click and say okay to that. I got a sheet metal part. Now what's so cool about this is I can actually come in and modify this if I need to. So for instance, this little tab out here that's straight, that actually needs to get bent in as well. And I want it to follow the same parameters that I see on this side. So I'm gonna come in, I'm gonna measure from this inside face to here. Now the reason why I measured it from that inside face is because I was originally working with a 1/4 inch material on it. Technically, this face from there to there is shorter than what was originally there because I extruded inward. So that's why I'm measuring from the inside. So we see from that face to here, it has a distance of 1/4 inch. And once again, I'm using the letter M because that's my shortcut key for measure. Coming in here, I'm gonna now activate the sketch bend command. From here, simply click on the line command and we'll come down and click on from there to there. Then we'll activate smart dimension and we'll go from there to there and say be 1/4 inch. Sweet. From here, we'll simply say okay. So now with sketch bend, what we need to do is come in and verify which side of my line is a fixed side. It's actually gonna be this side. So clicking on that, now what we need to verify is where is my bend position in relation to that sketch line. So I want it so it's bisecting it. So now that line is coming in and it's finding the midpoint there. Do I want to make it so that it's going so that the line is on the outside of my material? Do I want to make it to where my bend is on the inside of that line? Or do I want to offset? Well, in reality, since I measured from technically that line to this face here, which is equivalent to this inside face to the top face there, I'm gonna come in and tell it so that it's lined up here. So now we can see that those two entities are lined up and we simply say okay to that. If you don't have a total confidence in me by saying that, we can just simply do a measure command, click, and we'll see that we have a 1/4 inch thickness there. Perfect. So now the next thing that we wanna do is come in and add an edge flange here. Okay, so we'll come up, sheet metal, edge flange it. We'll simply click on that edge alone and drag it over and drop it. So with this new component here, let's say I want this so it lines up with this top face up here as well. So what we're gonna do is actually come in and under my flange position, we can come in and specify, all right, do we want it to come on the inside? We want it so that the bottom of this is in line with that, or we want to offset it up. Okay, those look decent. Let's look at it from the side though. Looks like we're not lining up properly though. And you know, if I do that, okay, fine. All right, fine. So watch this. I can actually come in and I can say, let's offset. So with offset set up, what I can actually do is say, let's offset up to surface. The surface I want is this one here. Now watch this. Notice how when I come in, I'm looking down the barrel, these two components are lined up. And so that flange position is being based off of this face here. Then from there, simply say okay to that. And that is coming in and converting a imported dumb solid into a sheet metal component. And then from there, we can easily come in and unsuppress this and see this in a flat pattern state and be able to cut this out on a laser cutter or water jet cutter or whatever form of CNC cutting you're doing. Perfect. So once again, my name is Peter. I really do appreciate you guys taking some time watching these videos. Hopefully you're getting some really cool nuggets out of it. If you are, please click that thumbs up button. Also click subscribe so you get notified for future Take a Break videos or other videos that we're posting here at Valley CAD. Have a great rest of the day and make sure you learn something new.